Hi, everyone. Welcome to this research seminar for the Department of Information Studies. With us today, we have Alberto Campagnolo. He will be talking about the digital lens on book materiality. And I'll let him sort of introduce himself as well and his projects. We are recording this for our records, and we will be uploading this on YouTube. And yeah, I'll just give the I'll give the microphone to you, Alberto, and you can just do an introduction and talk us through your projects. Thank you.
Thank you very much, Faustini, and thank you for inviting me. I was just thinking when I was preparing this that it's been almost 11 years since the first presentation I gave at UCL. It was when UCLDH was just starting up in 2014, and I was at the end of my PhD back then. So it's nice to come back, and in the years I gave a few in-person lectures when Summer Mahoney was there. But yeah, it's nice to keep on speaking with you, and it's always like one of my favorite places around. So I'm very happy to got the invitation to speak with you. So as an introduction, actually, I have a small slide that will have too much text on it, but it doesn't matter because it's color coded, and all you need is the colors. So it's just to give you an overview of me and why am I talking to you about digital and materiality, and why my research goes in this direction. So I trained as a book conservator. So everything you see blue on the screen, it's stuff that I did on places that I worked at as a book conservator. So hands-on working on printed books and manuscripts to conserve them and restore them. But I always had, since the very beginning, actually, some kind of interest into the digital. And eventually, as I was working in London as a book conservator, I applied for a master's in digital culture and technology at King's College London back then. And that's where I started entering the DH side of things. So everything is red, it's DH. So you see a lot more DH coming through after the masters. So I did a PhD at University of the Arts London in what used to be the Legatus Research Centre. It was a center that was devoted to the study of book bindings and conservation of books. And after that, I went on a series of postdocs here and there, and now I am assistant professor of codicology at KU Leuven in Belgium, and also senior researcher on a ERC in France because things get complicated. And at Leuven, I'm also the director of the Book Heritage Lab. So it kind of a convoluted and unusual path, but for me, really, it's not that I changed much. It's just that it always been interest into the book as an object. And before I was doing hands-on with like really scalpels and getting things very up close and personal with the books. And then over years, with my interest into the digital and the DH methodologies, I kind of started looking into ways in which all the things that I can tell about a book by looking at it in its materiality, and which is not usually translated into the digital, how we can take also that information in the digital, and so that we can exploit and use the technology in the same way that we can do for the text. There's a lot of things that happen over the years to digital text. When we go to the book as an object, that's not as much, but we are getting there a little bit at the time. So just to give an overview, because you never know who you're talking to, especially in these occasions. So for some of you, what I say might be very obvious, from others not. So I hope I keep in a level that is good for everyone. So books as object, what do we mean by this? it's really, we are looking at books as material culture. So books are very complex entities. And on top of preserving the text, in the way in which they are constructed, the materials that are used, and the structure that are put together to make the book that can work, and we can go and read too. There is a lot of data about the technologies that made the object possible, what material was used. And all of this can be traced back to some place and some time where things happened. Looking still at books, try to give an overview, and we can look at books under different perspectives, but three are probably the main concerns for us here today. On the one hand, definitely is the content. The book would not be there if there wasn't a text to be shared, usually, although there are blank books. It's also an object of use. People have used it and have left traces of these in the books, and also the way in which it's used guides the ergonomics of how the object is constructed. And on the other hand, it's also a technological artifact. So it's something that works because it mechanically works and the materials work in that way. Now, if we look into how things have been digitized, then we see that things are not as nicely spread. So definitely for the content, we have a lot. We have technologies to really get very high resolution images of the pages so we can read better. We can encode the text using TI or similar technologies. So on that part of the book as a content, there is a lot that has happened, and thanks God happened. When it comes to the object of use, there have been some attempts, especially in the early 2000s, where people were trying to mimic the way in which the book worked. And one of the famous projects was the Turning the Pages at the British Library, which, as I was starting my master's at King's 2006 and 7, was actually at the apex of their development. So they went into a full 3D modeling. They modeled how paper reacted differently to parchment. So there was a modeling there that was just not just turning the pages, but actually kind of mimicked how the material was working. But when it comes to the actual artifacts, so the things that I would like to see as a former or still a book conservator would like to study, there was not a lot. There is something here that's happened, and I will try to see how this happens. So just for the sake of understanding what we are talking about, I like to use this quote from a book that was published at the end of the 19th century, which is a later edition, 1902, by William Blades, that talks about the enemies of the books. And he, in one of his chapters, he talks about the books are like men. They have a soul and a body. With the soul, all the literary portions of the content, we have nothing to do with the present. So it doesn't care about the text inside. The body, which is the outer frame of covering, and without which the inner would be unusable, is the special work of the binder. So it is the body that we are looking at in this presentation. The soul is very important, but we will forget about the soul for the rest of this conversation today. So what happens when we digitize books? Usually, we take images of all the pages, all the sides, all the leaves that are within the book, and we end up with this sequence of images that represent the object that was there present and at the digitization. Now, there is a lot that can happen with these images, and the AAAF is one example where things really went and took these sequence of images to the next level, and I'm very happy about that. But if we consider that, for me, the book is the actual object, then things get a bit more complicated, and we need different ways in which we can harness these technologies. So for what concern books in the West, the quintessential form of book is the codex format. So the book that you think about when you think about a book, with the pages that you can flip over from one to another, with some kind of way to keep the pages together at the back, that is a codex. And if we try to give it a definition, I always go back to the Roberts and Skeet's definition in The Birth of the Codex, which they defined as a collection of sheets of any material. So there could be, used to be papyrus at the very beginning, then parchment, and then eventually paper. Folded double, so you take the sheet material and you fold it at least once. And you fasten this together at the back. So you have different pages that are kind of folded together and grouped, and then these come together to make up the codex. So the actual quintessential part of this, so the unit of the codex, as we understand it, it is the gathering. So it is these pages which are folded and then grouped together, and then one on top of the other, they make up the codex as that we use to read the book. So the gathering, the choir, so English has different terminology for the same things. So gathering is the term that I use because it's the more general one. Choir is used only for manuscripts, and sections is the term that's used only for printed books. I use the term gathering, which is the more neutral one because it covers everything. So gathering is the unit, the working unit of this object. But then when we go to the digital, we've seen those sequence of images, and we end up with sequence of images that have lost all connection. So the pages used to be connected when they were folded and creating these groups. And these now are they're floating in space. So it's what I call the floating pages paradox problem. We'll go back to this and see how we can deal with this. Now, as we said, digitization, usually it's taking images of these objects. And even if we just take sequence of images, we can still capture some information that is important to understand the book as an object and its materiality. So first we'll go through some straightforward visual means by which things can be gathered, and then we see how we can do even better. So we consider digitization at this point as capturing information through visual means. And I put there photography and imaging because some of the techniques that we'll be talking about are more advanced imaging techniques than just taking a picture with your phone or even an advanced camera. But if we consider just photography, we all know very well that that has given us access to a lot of information that was not available before digitization to the same level and respect. So on the one hand, we all learned over COVID that thanks God we have digitized books and we could carry on do some research at least from our own computers at home because we could access the digitized copy in the libraries. And these copies are nowadays such high resolution, again, thanks to mostly for the AAAF for what concern manuscripts and books. So the resolution is so high and nice that actually sometimes you actually see better things in the digital than you do with the manuscript in front of you. So all of this is already a step forward. And some of information about the codex and its materiality and its structure does come up in these pictures. Not much, but something comes up, especially because of the high resolution. We can go a step further and look into advanced digitization techniques. So we're still looking at ways in which we can point something to the object and get some information back. And but we're going to be more than just using a straightforward camera. So one technique that comes to mind when you talk about manuscripts definitely is multispectral imaging. What is this? It's basically in the most modern development that we have about it is you take a camera put in front of the object in a stable environment, and then you shine upon the object lights at different wavelengths, so that at the end you end up with a sequence of images, each one taken at different wavelengths. And why this is important, we'll get to in a second. So what you have really in the end, it's something like in this GIF here, where you see that the same page is being photographed over different wavelengths. And what does it mean is that for us, as for what we can see, it's basically going through the different colors of the rainbow. So there is some UV that we don't see. It's benign UV, so it's not harming the object. And then we go across the rainbow from the blue down to the green and orange and red, and then we go out of what we can see in the infrared. What happens is that we have this sequence of images all taken at different wavelengths. Now, this sequence that you see on the screen, it's actually a very important sequence because multispectral imaging, for what concerns manuscript studies, really started properly with the Archimedes palimpsest project. So this was a very important manuscript that was in private hand up to the 1990s, and then it went on auction and it was acquired by an anonymous donor that lives outside of the Washington, D.C. And he decided that he wanted this object to be studied and really imaged properly. Now, why was this important is that on this is a manuscript that was reused. So there are more than one text in the same pages. There is an underlying text, which is very important because it's some of the treatises from Archimedes that we don't have in Greek in other manuscripts. And then on top of it, there is another text that it's still of importance, but it's not the Archimedes text. With this manuscript was made out of parchment. Parchment is very sturdy, so you can erase some text that you don't need anymore, and then you use the same page to write another text. This is why we have more than one text in this case. But what really people were interested in was to read what had been deleted. So the Archimedes palimpsest, the Archimedes text. So palimpsest is just the technical word, comes from Greek palimpsao, scrape more than once, scrape twice, which is just the description of what happened. So what the anonymous donor wanted was like, is anyone doing any kind of advanced imaging to describe, to get this information from manuscript? And then that's how multispectral imaging started with the manuscripts. Now, why do we shine all these different wavelengths on the object? Is because materials react differently to different wavelengths. So this allows us to get more information and to differentiate information. For example, these Greek manuscripts from the Marciano National Library in Venice. What you see on the screen right now is one of the pages under normal lighting. If I go to the multispectral imaging set, this is the image that appears under the green light. The green light is where we see better. So usually the green light covers everything you see throughout the full spectrum. If I go towards the infrared, you see that things are different. So on here, this is the green, here is the red. All the text disappeared on this one. This is because the ink in which these manuscripts are written, it's iron galling, so it's an ink that actually has been around since the late antiquity, is made out of the metal reaction. So there is some iron there, which reacts with some tannins, gets inside the fibers, and this ink becomes completely invisible under infrared light. Which sometimes is actually useful if you are interested in some features on the page and you don't care about the text, as I often do. If you go into the infrared, you only see specific features that are on the surface, but you don't see the text that distracts you any longer, which is good. But what people really wanted to do was to extract the undertext there. So if you take your full stack of images, so all these images are taken at different wavelengths or registered, so the same pixel represent the same area of the manuscript in all images, and you can do statistical analysis to extrapolate data out of this and start to peel out areas that react similarly in the same under in the full spectrum of the imaging. And through this, long story short, people have been able to recover the undertext and read the Archimedes palimpsest. So they read the text that had been deleted. Now, this is what is normally thought of when we think about palimpsest and multispectral imaging, but multispectral imaging is not just for palimpsest. You can actually apply it to any kind of document to understand its materiality. So again, here we are at the manuscript from the Marciana National Library. This is actually it's quite an important manuscript. It was written. Sorry, it goes on. It was written in Crete in the 15th century, and it's an end of the world chronicle, basically. What we didn't know is that how the manuscript had been put together. Was it written and drawn at the same time? Was it all written first, all drawn first? So how we can understand that? And through the analysis of this multispectral imaging, we're able to differentiate different materials and really peel out how things had happened. So in this case, you see that as we've seen earlier, at the naked eye, the image, the color of the drawings and the color of the text look the same. They're both actually ink, but the drawings also has an underdrawing of a different material, which allows us to differentiate the two things. If we go to another page, which had also some corrections, this is where you can start to peel off the layers. This is just a false color image of the same data set. And we go to the deletion where there have been some decoration to cover up the deletion as well. So we are interested in this part here at the top right. What I'm using here on top of the false color imaging and the different ways in which we can look at the data, I'm using spectral curves, which I have found it make it much easier for humanists to understand this data, because it's basically just plotting on a graph the different ways in which the materials react to the full spectrum. So every point in the line is one of the wavelengths. And by looking at the shape, people really can understand better what they're seeing on these images. So long story short, what happened is that the text had been written first, and then the drawings were added. And then when the person was looking at the drawings, making the drawings, also looked at the text and then made some corrections and deleted the text with the new ink that was used for the drawings, and then made some other decoration on top of it in order to conceal or make it look better. So because of the two inks reacted differently, and because of the layering that we see here, we were able to see how the things had been written, in which segments things had been written. There's also a question about whether everything was done by the same hand or not, but that's for more research. It's, as we said, things react differently to different wavelengths, and the multispectral imaging allows us to understand where things are different and to plot these on an artificial image like the false color image that we've seen earlier. So it doesn't take a long time, and it gives you a good understanding of the different materials you have in one page. Now, after that, if you really want to go into more advanced techniques and getting real scientific data about it, then you need to apply different techniques that might help you to understand what you're seeing there. So XRF, if you have elements that are not too light, so from aluminum onward, you can really extract what elements there are in these pages, and the ink, because it's metal based, reacts very well to XRF. FTIR is another technique. Also, there are different ways in which you can really go point out the materiality of these objects. But multispectral imaging is a good way to start to have a full mapping. Another technique that has been used very early, actually, for at least book binding structures, it's X-rays. So again, it's a photography technique, but it allows you to get inside the materials. As we know, when you go to the hospital and get an X-rays of your, if you've broken your arm or something. And this allows us to see things that are not visible because they're covered or they are inside the structure. And X-rays had been used, as I said, from since the 1950s, actually, for what concerns bookbinding structures to understand how things were put together. Nowadays, we have even better techniques, and we are starting to see the application of CT scans and micro CT scans to really get inside the object and understand the structure better, or even how things are put together. The resolution nowadays has come to a point that actually we can get useful data out of this. If you take a manuscript and you put it into the CT scan you get in the hospital, you don't get resolution good enough to actually do something with it. But the micro CT scanning really gets us information that you can really trace back the gathering sometimes, as it is in the example here on the left, the stitching of the sewing. So you can really see a lot of details that in that particular case were not possible to see in other ways, because the book block is in a very bad state of conservation, so the pages cannot be opened at all. And so again, X-rays really give us a different way to get into the material. And we're starting to see that we are seeing things that are not text-based, but about the structure. Another good thing that has happened over the last few years is that, remember the sequence of images? It used to be that the sequence were only covering the pages with text. Then they started adding all the pages, whether they had text or not. Then they started adding also the covering. This is because, the cost of the pictures was getting lower and lower. You can do more with it. And as of, I don't think more than 3 or 4 years, actually, now you start seeing also pictures of the object from different points of view, like as we see here at the bottom, which, with the book found open or at an angle, which allows you to see some details that are not possible to see if you're taking the object just from one point of view or another. So this is static image, normal photography, but really gives you a different ways in which you can get into the object and understand how it might work. So I'm welcoming these new pictures very much. Another technique, though, that allows us to understand the three-dimensionality of the object is, of course, photogrammetry. And again, nowadays we are getting to the point where it's open for everyone. So the models that I'm going to show you in a second are done with just my phone in the normal conditions of the reading room as I was working on this manuscript in Cambrai, northeast of France. So photogrammetry, what it is you just take a sequence of images of the object from different viewpoints, trying to cover as much as possible and having the object always in sight in your images. And then you can run a sequence of algorithms through this data set so you can reconstruct the geometry of the object. So what you end up with is a 3D mesh of the object as it was captured through the images. Nothing new there, of course, but the good thing is that now you really can do it with a phone, and it allows people to really get information quickly and then study the object at home when they can't get to the object anymore. So these are some of the books that I was studying when I was in Cambrai. So these are Carolingian style bindings bound around the 12th century after the fire. And this is just an example of how things happen. So the structure here is actually quite complex because it goes on an angle, and the way in which the endband, which is this part of the book that is at the top, was sewn, is not easy to understand through normal pictures because it's always kind of covered. You don't understand how things are going. With the 3D model, which again, one can take very quickly with the phone and just a free algorithm, then you can start to really manipulate the object as it were in front of you, and this helps to study these objects and understand how they are put together more than just a set of images. The one extra thing that comes with photogrammetry is that, as the words say, it comes with measurements. And you can do measurements of the book, so you can do it on the model. The precisions here, it's probably plus or minus half a millimeter, which is way enough for what concerns bookbinding studies. So you wouldn't be more precise if you were taking measurements with the book, with your ruler, or things like that. So it's a good enough technology that I've been using a lot, more and more, because it really allows them to capture information very quickly and then work on the object off when I'm back at home. The good thing that also it's captured through this 3D model is the surface details, and you can start to understand what is happening beneath the surface as well. But there is a technique actually does this better, which is RTI or photometric stereo. They are the same technique, as in you are taking pictures of an object through different illuminations. So you take a static image and you take pictures illuminating the object from different points of view and directions. And you end up with a data set of all these different images. Now, the algorithms through which the geometry and topography is then reproduced and understood through the different images, it's a bit different between RTI and photometric stereo, which is the technique that was developed here at KU Leuven, which gives a little better results for the topography, because it takes into account both the reflectance of the object and the absorbance. But it's just just tiny details. The technique is basically the same. What happens is that it through this different illumination, you can see things that would normally be concealed. So this is the normal image that you will see of one manuscript as it is taken for digitization. So with a nice, even illumination that is very good for the text, but is also very good at canceling out everything you don't want to see. This is the actual topography of the object. It's parchment, it's also in bad condition, and it's really I find it's actually quite stunning, actually. And on top of the actual deformation of the topography, you can also see those lines that are there on the surface of the page, which are not so visible in the normal photography. And these lines are how the page was prepared to receive the text, which is also very important for codicology. Another application of RTI was done very successfully by Bill Andrews on the Saint Gospels. And he used normal RTI to take picture of the images and of the pages and understand how these are deformed, but also he looked at the actual geometry of the 3D mesh that can be produced through the RTI, and realized that actually the 3D mesh was giving out very clearly the stress line on these pages, and predicting why some of the pigments had gone and where pigments actually were at risk of being lost over time. So it gave a lot of information for conservators to really start to look into where the area of importance where things might be lost very quickly. So we've seen different ways in which we can extract more than just textual information from these objects. And we've seen that, you have different techniques to do different things. And all of this has been described as slow digitization by Andrew Prescott and Lorna Hughes. And it's really a variety of tools to get layers and layers of information so that we can get more information out of these objects. But not everything can be acquired through just images. Even very advanced images, even CT scan don't acquire everything. So there are things that I need that go beyond direct acquisition digitization. So I still consider the ways in which I can get this information out of this object digitization. It's just that I need to revise the definition of what we consider digitization. So if we don't consider digitization only the taking images of something and even advanced imaging, but we redefine digitization as any direction that can be directed at computerizing, making information available for us to use in the computer. Then we can look into ways in which we can transmediate more information into the digital and use this as extra layers of information on top of everything that we already acquired through slow digitization. And as it turns out, which is of course not surprise to anyone doing DH, is that models and metadata are techniques in which we can model and extract and extrapolate and transmediate more information into the digital. And we'll be looking at one particular feature. Looking at the time, yeah, we're good. So the gatherings we saw, they were important part of the codex, completely lost in the digital because there are these floating pages that are not connected anymore. What normally happens is that the ways in which the pages are connected to each other within the books and codices, these are usually described using collation formulas. And if you do not understand what you see on the screen, do not worry, because actually even if I understand them all very well, all of them are using different styles. So all you see on the top are taken from the literature from manuscript studies. There's no standard. So each catalog, each scholar uses their own ways of doing this. There are schools, but even that they don't always overlap. For printed books, it's a bit better. It's a standard, but it's a very complex standard. So what happens is that you have a lot of information there. The information is there, but it's so compact and so highly coded that it's actually very difficult to make sense of it. To the point that oftentimes when a collation formula is written, it's taken as a dogma and then transmitted over and over from different catalogs and scholarly papers, even though it doesn't reflect anymore the object because things have changed, or even they made mistakes and it never actually represented the object, but they're taken as this thing, as dogma. One project that has been trying to tackle this is VSCO. So VSCO started when I was doing my PhD in 2013 as a conversation with Doug Porter at the Schoenberg Institute for Manuscript Studies at UPenn in Philadelphia. And it's basically an ecosystem of a model, an XML model that describes how pages are within a codex structure, and then ways in which this information can be output and visualized, and also how we can map more information concerning the object on this structure, which we said was the core of the book as a codex. All it is at the core is an XML model, and this is just a pseudo XML of one of the leaves. And so all the leaves are described, and each leaves will be either conjoined or not with another to create a fold that put all the pages together. Once you have the XML, as we know, you can do things with it. And one of the things that I've been doing since when I was doing my PhD for book binding structures, we did for these data about the collation, so the gathering structure of books. And you have the model, you write your XSLTs, and then you end up with diagrams that represent how these images, how these pages were inside the codex. And you can get to very complex structures. So I have no idea how to represent this structure that you see on the screen with a collation formula, but this is an actual manuscript that I was working on when I was as a conservator at the Vatican Library. And the structure here is very important because the structure tells you the story of how this book was written. It's a book of poems from the 16th century, and the poet was writing and binding the book at the same time, and he was adding pages to add poems to the structure or pasting pages on top of each other to delete sequences that he didn't want anymore. So the structure is very important for the philology of the text as well. And this is an extreme case, but there are many more cases like this one from the Marciana National Library, where a lot of pages have been added through the history of the codex. So things can get very complicated with manuscripts. And what you see on the screen, both here and here, is that these are diagrams that are automatically generated by the computer. So because you have the good model, you can do this advanced visualization of the structure. Another other layer of this is that because these diagrams, if you know what you're looking at, are quite immediate and easy to understand, by having the computer reading your model and then spitting out the data that you put into the database as visual, it's much immediate to see whether there were mistakes, because it's quite easy to make mistakes as we do. But because the data comes out in completely different ways, we don't look at the XML, we don't look at the tabular data, but we look at the diagrams, then we can go back and say, okay, no, this is not what I meant. This is how the structure actually works. Okay. Yeah, good. So this call, it's the model, but it's also how we visualize things. So on top of the diagrams, there is also an HTML visualization that shows the diagrams, but also shows you the images of the pages that used to be connected. So the pages that you see there are not in a sequence, but they are the pages that are physically connected on the object, which try to tackle the problem of the floating pages. And sometimes these floating pages actually they used to be together in the object and they are no more together. So this is the pages from the Gaelic Syriac palimpsest, so another palimpsest. The core of the material is next to the Archimedes palimpsest in this private collection out of DC, but there were pages all over Europe, and some pages were actually at the Vatican. And of course, now the pages are still at the Vatican and the core is out of the sea, but these pages used to be connected physically and now they are reconnected virtually through the VSCOL model and the VSCOL visualization. Now, the good thing is that for people, I work a lot with conservators who love to do these things, but they don't want to work with XML. So we have a visual interface now called VC Editor, which allows you to never have to look at the XML. You just put data into the visual interface, and the data behind it is collected as the XML, and then you can do the transformation afterwards. The last point that I want to point to is that usually there are two terms that are used as synonyms: physicality and materiality. And actually, I make a very clear distinction, and taking this idea from Catherine Hayes, actually, because this is important for me to understand how things can be digitized. So the physicality, it is actually the object. It's the infinite set of information that we can get out of an object that are inherent in its essence, being here in the world. Whereas materiality is an emergent property. It depends on the attention of the viewer. So what do you want to see in the object? What are you interested in studying? What is your entry point on the object? And each one of you will have a different entry point. And each aspect that you want to study will have a different entry point, which means that through this layering on information, we can create what has been referred to as digital culture object. So it's an object that's been digitized through different means, different layers, different ways in which we can represent the object. But there will be things that have not been covered yet because the materiality is just one aspect out of the infinite set of information that's the physicality. So there will be things in which we need to go back to the original object. So the digital is never a substitution for the object. It's just another way to study it. And then we find ways in which we can add this information to the digital cultural object, and we create this infinite loop that allows us to study both in parallel. And with that, I finished.
Thanks, Alberto. That was really great. Thank you so much. I will stop the recording now so the questions can take place.
Yeah.